Hi, everybody. This is Miss Peachy from your WCA Earth and Space Science class, and I am here doing a very short video tutorial to explain to you what you need to do for the Math Rocks the Earth Half-Life portfolio, which is the next one here on your agenda. So, as you can see, I have opened up the um, lesson viewer, lesson 12, Math Rocks the Earth Half-Life from Unit 2. And I'm just going to take a brief moment to kind of go over what you need to do for this and to briefly go over the math involved as well. It's really not that difficult, but I just want to make sure you know what you need to do. So it's talking a bit about Half-Life on slide 1. And then on slide 2, it gives you 3 problems that you need to do. So you need to do these problems. I need you to show me your work. Just give me answers. Show me the work for them. I will just return it back to you if all you have is answers for this. So I do need to see work. And then you're going to submit your answers to the questions as attachments to the lesson. So pretty simple. If you feel like you want to do this just on a piece of paper and show me your work that way, that's totally fine. Just take a picture of your paper and send it in. If you would like to do this like on the computer and kind of save your work using just typing it in, that's fine too. Completely up to you. So we can kind of look at that here in a moment. But first, let's talk about what Half-Life is and how you're going to do these problems. So we talked a little bit about this in class, but I just wanted to kind of go over it with you again. That half-life is the amount of time it takes for a radioactive element to decay into a stable daughter element, for half of the amount of it to decay into a stable daughter element. So radioactive elements are those that are unstable, and they lose particles from their nuclei and they change into a more stable element, and it takes time to do that. Depending on the element, that time is different, right? Sometimes it takes just a few seconds, sometimes it takes hours or years or even millions or billions of years to change into the stable version or the stable element. So when we look at about the amount of time it takes for half of it to decay, we call that time period the half-life. So as you can see here in the example, say we have 8 uranium atoms here. We call that the parent material. And uranium will decay or change into lead. We say decaying because it's losing particles in order to be able to become lead. That's why we call it decaying. Lead is then known as the daughter material. So when 4 out of 8 of those uranium atoms have changed over, that occurs during the half-life of uranium. So in that period, it takes 1/2 of those elements to change over. That time frame is called the half-life. Then we only have 4 left uranium atoms, right? So a half of 4 is 2. So another half-life will have to pass in order for the 2 of them to decay into lead, leaving 2 behind. So again, half of what you have left. The time period is the same. So the time it took to go from 8 to 4 is the same time as it takes to go from 4 to 2, right? And then we only have 2 left, and again, that same time period passes, and we go from 2 to 1. So we're always reducing by half what we have left. So you don't look at what you have in lead, you only look at what you have left of that radioactive element. So we're going to do a little problems with that, some math. So the half-life of carbon-14 is 5,730 years. That's the time it would take for half of the carbon-14 to decay into its daughter, which is called nitrogen-14. So if we start off with 240 grams, how much would we have left after 3 half-lives? So you have 240 grams that you start with, and you have 3 half-lives. Well, the first thing we need to figure out is the amount of time that has passed in order to tell us basically how many half-lives we have, right? Or how much time, I guess, is in 3 half-lives. So 1 half-life is 5,730 years. So 3 half-lives is 3 times 5,730, which is 17,190. So that's the amount of time we're talking about, okay? So that tells us kind of a little bit about, how long of a period it actually is. So if we take the elapsed time of 17,190 and divide it by the 5,730, we end up with 3, which is the same that they gave us in the problem. So in this case, you actually are given that information to begin with, but if you weren't told how many half-lives it was, then you might have to figure out how many half-lives it is. Then once we get that, we use the number of half-lives, which is n here, and we use it in a little math problem to figure out how much we have left. So we take the beginning amount, which is that 240 grams, and we divide it by 2, and then we put it to a power, or we have an exponent here, which is n. And that means that you're going to raise 2 to the 3rd power, because n, remember, is the number of half-lives, which is 3. So if I take the beginning amount here, I'm going to use my little tablet here. Just move this over. Here we go. Okay, so beginning amount is 240 grams, right? And we divide it by 2 to the 3rd power. And remember that 3rd power, this number right here, that's the one you have to try to figure it out. That is going to be your number of half-lives. Well, 2 to the 3rd power is just 2 times 2 times 2, which is 8, right? So we're going to take 240 and divide it by 8. Well, this is actually a pretty simple problem because 240 is exactly divisible by 8. It should give us 30. And that's how many grams we should have left. So let's go back to the actual lesson. So it shows us 240 divided by 8 would give us 30 grams. So we end up with 30 grams, right? So we have a different example that's given. Let's say we have cobalt-60 as a half-life of 5.26 years. So that's our half-life, right? And it says if we have 90.51 milligrams and it decays over a period of 18.41 years, how many milligrams do we have left? Well, now they're not telling us how many half-lives it is. They're just telling us how much time has passed. So this is getting a little bit more difficult, but not really all that difficult. Because remember, first thing you need to do is figure out how many half-lives you have. So if you have a total of 18.41 years and each half-life is 5.26 years, right? So let's move this over here. 18.41 years is the total amount of time. And every half-life is 5.26 years. So we're just going to figure out how many half-lives it is by taking the total time divided by the length of one half-life. Now, I can't do this one in my head, so I'm going to have to bring out a calculator for this one. So you're going to need to have a calculator, right? So 18.41 divided by 5.26, which gives me a number, as you can see there, 3.5, right? So 3.5 half-lives is what we have here. Okay. So then let's go back to the lesson somewhere in amongst all of my things. So again, they did the same thing as their example, figured out 3.5 half-lives. We take the amount of stuff we have in grams and divide it by 2, and you raise it to the 3.5 power. And this is where you might be like, I have no idea how to do that. Okay, so we're gonna go and we're gonna take, oh shoot, I forgot how much stuff we started with. What was the number? So we start with 90.51 milligrams. And we divide it by 2, but the exponent here is 3.5. Okay, so let me just show you a little fun tool on your calculator. Now, my calculator may be slightly different than yours, but it kind of depends on your calculator. So for me, I'm just going to figure out the bottom first. I'm going to figure out the exponent. So I'm going to go, I'll put it up here, but I'm going to go 2. And then I'm going to use this little key that says y to the x right up there. You see it? Hit that and then hit 3.5. Whoops. Right? And then if I hit my equal sign, it'll give me the value of that, which is kind of a long decimal, 11.331. So I'm just going to actually just round it. So this bottom number is 11.31. The other tool you might have on your calculator, you might have a little caret, which looks like it looks like this. So that might be what your key looks like. It might be a little caret like that. Okay, that also means exponent on your calculator. So mine is a y to the x key, looks like this. Sometimes it's a little caret like that. I'm curious because if you have a cell phone, you can also use the calculator on your cell phone. And if you take your cell phone and you rotate it, this is for the iPhone, I don't know if it's true for all phones, it becomes this type of calculator, a scientific calculator. On this one, it is an X to the Y key, so it's very similar. It's right there. Instead of saying Y to the X, it's X to the Y, but it's the same kind of key, right? So just have to locate the right key on your calculator. If you can't find that, just ask me. We can, meet in live lesson and I can just look at your calculator and show you where your exponent key is if for some reason you can't figure that out, okay? So again, we're going to take 90.51. That's the amount we start with, right? That's how much we started with. This is 2 to the number of half-lives. So take 90.51 and divide it by 11.31. Excuse me. And I have about 8. So, I mean, it's 8.0026, but I'm going to go with 8. Okay. So that gives me 8 milligrams is what I end up with at the end. And let's just double check and make sure we did that properly. Yes, and that's what they end up with as well. Okay. So that's kind of what you do. Remember, you first have to figure out the number of half-lives. Then you take the amount of stuff that you have and divide it by 2. And then you raise that 2 to the exponent of the number of half-lives. So what I do is I always solve the bottom part first, and then I take the top and divide it by the bottom in order to get the total answer. So you're going to do the same thing here. You're going to have an element has a half-life of 30 years. If 1.0 milligrams of this decays over a period of 90 years, how much would remain? So again, you start with 90 years. The half-life is 30. How many half-lives is that, right? And then you just use that formula where you take the amount that you start with, which is 1 milligram, divided by 2 to the n. The exponent, again, is the number of half-lives, okay? So do the same things for number 1, 2, and 3. You are going to show me your work like we did here. So you're going to show this. I would write here this is number 2. right? This is number 1. Whoopsies. So you can do this on a piece of paper. Again, you can scan it or take a picture of it and attach that picture so I can see it. I have something that you can do if you don't have a scanner, you don't know how to do the pictures and stuff like that. I have something else that might work for you. Okay, now this is just a cool thing on Microsoft called Microsoft Whiteboard, but there is a similar thing on the computer. If you go to Google and you go to this little app pad down here, you can go all the way down to something called Jamboard, which we've used in class a few times if you come to class, but if you haven't, then you might not have seen it. And you can, let's see here, here, hit the plus, start a new jam, and you have tools on here. You've got a drawing tool, so you could literally do your math right here. You know, you could do this and send, and then basically all your work is going to be on here. Then you can just share it with me, right? But just make sure that when you share it, that you change this link here so that you change it to anybody with the link. And then what you can do is you can copy and paste that link into a Word document and send me the Word document with the link. That way you can still show me all your work, but it's not, if you don't have, the paper, well, obviously you have paper, but if you don't have the ability to scan or take a picture of the thing you did pencil paper. Okay, so I want a digital copy. I don't want you guys sending these in through snail mail, through the white envelopes. It's just too difficult to do that, and it's too time consuming. So digital copy only. You can send me a jam here if you want. Again, share that with me. Or, like I said, do it on a piece of paper, and you can copy paste it and send that to me. So some digital way or a piece of paper that you've either scanned or taken a picture of with all of your work. All right, ladies and gents, hopefully that all makes sense to you. If you have any questions, if you have any concerns, if you don't know where to find the exponent button on your calculator, please send me a webmail and we will be able to solve your problems in a live lesson. Have a great day, everyone.